To solve a system of equations with using matrices, but rather than using the calculator as in the previous examples, we are going to do it by hand by turning our matrix into reduced row echelon form, or for short, that's what the RREF, which is what we did in the graphing calculator. That's what it means. So in this case, we're going to do a few operations on matrices. The three elementary row operations are: number one, two rows in matrix can be interchanged. Number two, elements of any row can be multiplied or divided by any number except 0. And then the one that we're going to do the most, which is number three, which is that the elements of a row can be added to another row or multiple of another row. So let's just look at one example to see this in action. All right. So we're gonna look at this system of equations. It's very similar to one that we have already solved. Well, so let's do this one by hand this time. So number one, let's write this system into matrix form. So again, all we do in this matrix is to write down the coefficients of the variables, but not the letters. 1, 1, 1, and then the bar to delimit the constant coefficients, and then 2, negative 2, negative 1, negative 7, negative 3, 1, 5, and 5. Alright, so what are we going to do in this case? Well, so our goal is to turn the matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9, a matrix of this form. We want to reduce that where all these dots are just numbers. What we want to do is to have a main diagonal of 1s and 0s everywhere else. And then this number is going to give us the x, this number right here is going to give us the y and the z. So what are we going to do? So we are going to start with the 1, 1 element. And in this case, we want to make sure that it is a 1 and then turn this into zeros. So lucky for us for this system, we start with a 1, which is great. And then we need to turn these two into zeros. So what are we going to do in order to get that? Well, so we are going to do two elementary operations. Number one. So we are going to multiply the first row, because of this first row, the one that has the 1 to 1, this element right here is going to be called the pivot. The pivot, which is used to turn these two elements that I'm pointing to into a 0. So what we do is multiply the first row by the opposite of this coefficient and that coefficient. So in other words, the first row, the first row times negative 2 plus the second row to obtain a new second row. So that's what we are going to do essentially. All right, that's one operation. And in this case, I need to do another operation. I should have written this with pink. That's the first row. In this case, the opposite of negative 3 is positive 3 plus the third row to obtain a new third row. Let me show you how it works. Well, typically, if you read the textbook or if you have seen this before, typically we're asked to do this in our heads, but I don't want to do it in our heads. I'd rather write this instead. So what I'm going to do is the first row, I'm going to write the elements 1, 1, 1, negative 3. I'm going to multiply by negative 2, and I'm going to add those to the second row. So I'm going to do in other words, what I'm going to do is the operations on the side. All right. So this is what we do. Negative 2 times 1 is negative 2 plus 2 equals to 0. Negative 2 times 1 is negative 2 minus 2 equals negative 4. Negative 2 times 1 is negative 2 minus 1. Be careful with signs. Negative 3. Negative 2 times negative 3 equals positive 6. And positive 6 minus 3, minus 7 rather, that's a negative 1. Alright? Let me do the same with this first row as well. So that's a 1, 1, 1, and negative 3. But in this case, to obtain a new row, so this is a new row 2. I'm going to obtain a new row 3 this time. So I'm going to do the operations to obtain the row 3. So I'm going to multiply this by, in this case, 3, and add to the third row. Alright, so add these two rows. So what I'm going to do, 3 times 1, which is 3, minus 3, that's the 0 we wanted to obtain. 3 times 1, which is 3 plus 1, which equals to 4. 3 times 1 equals to 3 plus 5 equals to 8. 3 times negative 3, that's negative 9. Plus 5, that's a negative 4. And this is our new row 3. Okay? So what are we going to do? Let's go back to the new matrix. So the first row remains the same. And then this becomes the new second row. 0, negative 4, negative 3, negative 1, and then 0, 4, 8, negative 4. All right, so we have reached part of the first part of our ultimate goal, to have a 1 and zeros below. So now I'm going to move to the second column, in which I will find a way to have a 1 here and a 0 at the top, a 0 below. Alright, so, but in this case, the element 2, which is going to be our new pivot, it's not a 1, it's a negative 4. So in this case, we can use one of the properties of elementary row operation, which is to multiply or divide the entire row by a non-zero scalar. So in this case, we have a couple of options. Number one, well, we could divide the entire second row. But do you see a problem with this? Well, the problem with this is that if I do that, we're gonna have fractions, because we're gonna have 3/4 and 1/4. So we may not want to do that. However, if you observe the third row, all the numbers right here are divisible by 4. You know, they're all divisible by 4. And then, so what I can do is interchange these two rows, row 2 and row 3, and then divide the third row, or actually the new second row, by, by 4. So this is what I'm going to do. The way we denote interchanging two rows. So I'm going to do an arrow to keep going. And this is what we do. Row 2 is getting interchanged with row 3. So the first row remains the same. And then we just interchange these two rows. So 0, negative 4, negative 3, negative 1. So, and this is what we're going to do. So to obtain this one right here, what we are going to do here is to divide the second row by 4, or multiply by 1/4 to obtain a new second row. So what are we going to do here? The first and the third rows remain the same. And then the new row, well, all the elements, divide them by 4 or multiply them by 1/4, which is the same. 0, 1, 2, and negative 1. All right. So now we have that one as a pivot that we want. So we want this 1, 1. We need 0 and 0 over here. So how are we going to do that? Well, so we need to do essentially two operations here. To turn that into a 0, I need to multiply the second row by 4 to add with -4 to give us a 0. And then on the other hand, for the top row, to have a 0 here, I need to multiply the entire row by the opposite, which is -1. And that's exactly what am I going to do here. So in this case, what we do, so let me do it this way. So I have enough space. So I'm going to do this. And then I'm going to denote, well, so the -1 times the second row plus the first row to obtain a new first row. And then I'm going to do 4 times the second row plus the third row to obtain a new third row. So those are the two operations that we do. Let me write down the second row, 0, 1, 2, -1. Multiply that by -1 and add it with the first row. So let's see. So -1 times 0 is 0 plus 1 is 1. -1 times 1 is -1 plus 1 is 0. Actually, the 0 that we want. Yes. -1 times 2, that's a -2 plus 1, that's a -1. -1 times -1 is +1 minus 3 equals to -2. Let's do the other operation. The second row times 4 plus the third row. So let me write down the second row first again. And add it with the third row, 0, -4, -3, -1. And that first row times 4. And then add these two rows. Here we go. 4 times 0 equals 0, plus 0, 0. 4 times 1 is 4, minus 4 equals 0. That's the 0 that we wanted. Of course, 4 times 2, which equals to 8, minus 3 equals to 5. 4 times -1 equals -4 minus 1, that's -5. Okay, so this is going to be our new row 1, and this is our new row 3. So what are we going to do? We're going to write down a new matrix. In which the second row remains the same. And then the new row 1 is going to be this one. 1, 0, -1, and then -2. And then the third row equals 0, 0, 5, -5. All right, so we have reached the second part of our ultimate goal, to have a 0 here and zeros above and below. So now our next goal is to have a 1 over here and turn these two into zeros, which is this part right here. Turn this into a 1 and make these two zeros. All right, so number 1, this one is going to be really easy to do, no interchanging rows, because if you look at the third row, all we need in this case is to divide the third row, R3, to obtain a new row 3. We need to divide by 5 or else multiply by 1/5. Okay, multiply by 1/5. Okay, that's multiplication. So all we do in this case, well, so that's 1, 0, -1, bar -2, 0, 1, 2, -1, and 0, 0, 5, -5. All right. Oh, wait a minute. No, I didn't change that. Give me a second. That should have been 1 and -1. All right. So we are ready to do this. We're ready to do this very last operation here. So number 1, we have this one. I need to get rid of these two by adding the opposite, the additive opposite of that, which in this case is -2. So the third row times -2 plus the second row to obtain a new second row. And then I need to do the opposite. Well, in this case, notice that 1 and -1 are already in opposite signs. So all we have to do is combine those two rows together, R3 plus R1, to obtain a new R1. Okay, I'm gonna do it again doing the operations not in our heads, but actually writing them the same way I did it here. So I'm gonna write the third row, which is 0, 0, 1, -1, add it or multiply that by -2, and add it to the second row, 0, 1, 2, -1. Okay, -2 times 0 plus 0, it's also 0. -2 times 0 is 0 plus 1 is 1. -2 times 1 is -2 plus 2. That's the 0 that we wanted over here. -2 times -1, that's +2 minus 1. Be careful. That's 1. And that will be our new second row. And then the last operation, which is R3, plus R1, which is actually that's a 1, 0, -1, -2. Well, in this case, we're just adding them. We're not adding a multiple of it. So 0 plus 1 is 1. 0 plus 0 is 0. 1 minus 1 is 0. That's the 0 that we wanted here. And -1 minus 2, that's a -3. So let's write down the very end of this matrix, the very last step of this matrix operations, in which, well, the third row remains the same this time, and our second row will look like this: 0, 1, 0, 1, and our last row, our new first row, that's the new R1, will be 1, 0, 0, -3. And that's our ultimate goal: main diagonal of 1s, zeros everywhere else. And that means, well, x equals to -3, y equals to 1, and z equals to -1, as you can compare with the exercise that we did using the graphing calculator. Alright, so this is the end of this video. I'll see you in the next one.